Hello everyone, welcome to Homework 13. This is the first part of your exponent review. Again, this is not going to be for pre-calculus, but after pre-calculus. And if you took CPM 3, you have actually already done all of these. So if you need this video as a quick review, you can use that. But if you were in CPM, hopefully you remember these rules. And again, that's CPM 3, not 2. So these are going to help you whenever you get past calculus. You should actually be using it a little bit in your pre-calculus class, but this is mostly a review for afterwards. Especially next part is going to be really helpful for calc. So the first one is your product rule. If you have the same base, that's base A, then whatever these exponents are, you can add them together. Okay, and you have an example down here. The biggest thing is, especially whenever you have numbers, a lot of times people want to multiply those numbers together. You got to make sure you're keeping the same base. So you keep the base, add the exponents. Okay, and so just to kind of show you why this works, if you have something like x cubed times x squared, x cubed just means you have x times x times x, right? You've got 3 x's. And then times x squared, which is x times x. Well, how many do I have now? I have 5. And so that becomes x to the 5th. Okay, so down here, x to the 4th times x to the 6th. Technically, what we're doing is 4 plus 6 to get x to the 10th. B, you have the same common base, so we're not going to multiply those. It's going to stay -5. And then 7 plus 8 gives me 15. Here, y cubed times y, it says don't forget if there's not an exponent, there's a known 1 there. So that becomes y to the 3 plus 1 to get 4. Here you've got 3 different terms, but they all have the same base. So add up all the exponents. 3 plus 2 is 5. Plus 7 gives me 12. Now it can sometimes get a little confusing whenever we have coefficients in front of our terms. We still multiply our coefficients like normal. So 5 times 4 gives me 20. And then z to the 7 plus 8 is 15. So you can see why it gets a little confusing, because I am multiplying my coefficients, but then you got to add your exponents. So then F is the same thing. We've got -3 times 7 to get -21. And then add your exponents with the same bases. So a cubed times a squared is a to the 5th. And b cubed times b to the 4th is b to the 7th. Multiply your coefficients just like you always do, but the exponents you add together. We have a power rule. When you have an exponent to an exponent, this is when you multiply the exponent. So keep the base, multiply the exponents. And so you can see that right here. The reason is, if you have something like x cubed all to the 2nd power, that x cubed is my base, and that means I have 2 of them. Let's do it this way. Let's do a 4. So my base is x cubed and we have 4 of them. So this is x cubed times x cubed times x cubed times x cubed, right? You got 4 of them. Then add your exponents now, because these are all being multiplied. This is our last rule. So 3 plus 3 plus 3 plus 3 is x to the 12th. So we could have just multiplied those together from the very beginning. So example 2, use the power rule to simplify your expression. Y to the 8th all squared is y to the 16th. Eight to the 4th all to the 5th power. 4 times 5 is 20. Z cubed all to the 7th power will be z to the 21. So we've only gone over 2 rules so far. We've got a lot more to go through. I think 4 or 5 more. So as we tack these on, you've got to figure out, how do you know when to use each thing? And so that's what this little helpful hint is telling you right here. When you're using the product rule, you add your exponents. When you use the power rule, you multiply the exponents. So how can you kind of tell the two apart? Here, your bases are being multiplied together. And then here, you have a power to a power. A lot of times when I taught CPM classes, they would say parentheses. Those parentheses give you a hint to multiply. So kind of going along with this last one, we have a power of a product rule. So if you have 2 things inside parentheses, that exponent goes to everything. So you can almost think of it as distributing that exponent. Okay, and again, here's your reason why. If you have x squared, y cubed, and this is all to the 4th power. This is x squared, y cubed times x squared, y cubed times x squared, y cubed times x squared, y cubed. Add your exponents with the same bases. So x squared, x squared, x squared, x squared. 2 plus 2 plus 2 plus 2 is x to the 8th. And then 3, 3, 3, and 3 give you y to the 12th. So what could we have done? We could have done 2 times 4 and 3 times 4. I hope you agree that's a lot faster. You have another example of that right here. But example 3 says use the power rule and the power of product rule to simplify the expression. So st all to the 4th means that's s to the 4th, t to the 4th. It's that simple. On B, it is simple, but you do have to be careful. A lot of times whenever we have a coefficient, we forget to distribute that exponent to it as well. So this becomes 2 cubed, a cubed, and we can simplify this. 2 cubed is 8, so my final answer is 8a cubed. Whenever you have a number to a power, you want to simplify that. I didn't do that here, and I didn't do it on another one because the exponent's so big. If I have 8 to the 20th power, if you put that in your calculator, that's insanely big. But something like 3 cubed, that we need to multiply out and get a number. Okay, same thing here. Don't forget this coefficient in the front. So 1 third cubed. That's 1/3 times 1/3. Multiply straight across. 1 times 1 is 1. 3 times 3 is 9. So we're going to get 9 there. 1/9, sorry. So we've got 1/9 m squared, and then n, 3 times 2 is 6. Power to a power, you multiply. Same thing here on D. Don't forget that coefficient, and that coefficient goes in parentheses. So -5 in parentheses squared is going to come out positive. So I've got 25 x to the 4th, 2 times 2, y to the 6th, 3 times 2, and z squared, 1 times 2. You have power of a quotient, which is the same thing. If you have a fraction in here, that exponent goes to everything in top and everything in the bottom. So really, when we did 1/3 squared, what did I say to do? We did 1/3 times 1/3. This right here is telling me that that is the same as 1 squared over 3 squared, which still gave me 1/9, right? Okay, you have an example of that here. But you have a fraction that goes to everything in top and everything in bottom. So that's just simply m to the 7th over n to the 7th. You've got multiple things in the bottom. It goes to everything in the bottom. So I've got x to the 12th, 3 times 4. You've got 3 to the 4th. 3 to the 4th is 81. And then y to the 20th, 5 times 4. You have a quotient rule for exponents. So if you have the same base, a on bottom, a on top, whatever those exponents are, we are subtracting. Okay, if you have something like x, well here, I'll just use this first example here. X to the 5th over x squared. That would be the same as x times x times x times x times x all over x times x. So here, cancel an x on the top and the bottom. Cancel an x on the top and the bottom. How many am I left with? We're left with an x cubed. So what could I have done? We could have done x to the 5 minus 2. Okay, same thing here. You've got the same base, 4. So subtract your exponents. So 7 minus 3 gives me 4 to the 4th. 4 to the 4th, I think, is 256. Let me see. Okay. You've got the same base here. So I've got -3 in parentheses. 5 minus 2 gives me 3. We can evaluate that. That's going to give me a -27. Okay, on D, what do you notice here? Those bases are not the same. If those bases aren't the same, we can't simplify anymore. So this here is fully simplified. I don't know if I spelled that right, but fully simplified. Okay, and then on E, when you have those coefficients, treat them how we always have. Whenever I have 10 over 2, that becomes 5, right? I'm dividing. You don't subtract, that doesn't become 8. 5 divided by 2, 10 divided by 2 is 5. So I've got 5. We've got x to the 5th and x. So 5 minus 1 gives me x to the 4th. And then y squared over y. 2 minus 1 is 1, so y. And then the last rule we have is the zero exponent. Anything to the 0 power is always and forever 1. Okay, as long as that base is not 0. So 0 to the 0, that's a different ball game. But if you have anything else to the 0 power, it is 1. And again, the reason is, if I have x cubed over x cubed, you have the same thing on top as you do on the bottom. What does that always equal? That always equals 1, right? 5 divided by 5 is 1. 10 divided by 10 is 1. If you use the quotient rule, 3 minus 3 is 0, and so therefore that equals 1. Right? Because this equals 1. And if this is equivalent to this, then these must be 1 as well. I guess I'll leave that up there. Okay. Now, these can get a little bit tricky. You've got to figure out what your base is. This one's not as important to us, this little thing here. But notice that here, my base is -3, and the reason that negative is included is because it's in parentheses. When you have this not in parentheses, the only thing that that base goes to is what's directly in front of that. So you've got -3 squared, and -3 squared is -9. If you put these in your calculator separately, if you put one in with parentheses and one without parentheses, one is positive, one is negative. Okay, it all has to do with what that base is. So here, 3 to the 0, that's 1. Because you have parentheses, this whole thing right here is to the 0 power. That's 1. -5 in parentheses to the 0 power is 1. But D is -1. All that exponent of that 0 is going to is that 5. So 5 to the 0 power is 1, and then that negative's got to get carried down. E, some fraction, any fraction to the 0 power is 1. 4x to the 0 power is 4. That exponent is only going to x. So that means we have 4 times 1, and so you get 4. If we had a g, and it was 4x in parentheses to the 0 power, that would be 1. So pay attention to what that base is. Look for parentheses. So that is literally all of our rules, but you've got to know when to use what rules. And in these cases, we've got multiple rules going on at the same time. So let's look at our concept checked here. It says, suppose you're simplifying the expressions. Tell whether you would add the exponents, subtract the exponents, multiply the exponents, divide the exponents, or none of these. A little hint, there's not a rule that tells us ever to divide exponents. So on A, you have a power to a power. When you have a power to a power, that means you are multiplying. B, y to the 15th over y to the 3rd. I think that might be why it has divide exponents here. Maybe that's what you think. You want to go y to the 5th. But this is your quotient rule, and your quotient rule, tells you to subtract. Z to the 16th plus Z to the 8th. This one here is going to be a none. Okay, there's nothing for whenever we add terms together. And these even wouldn't be like terms because they got different exponents. So just none. And then on D, W to the 45 times W to the 9th. That's your product rule. Your product rule tells you to add. So on 7, or example 7, we need to simplify these expressions. Some of these require us to use more than one rule in a problem to simplify. On A, you've got, this is your power of a quotient rule. You got to distribute that 2 to everything, including what? Including coefficients. So 3 squared is 9. Y cubed to the 2nd power is to the 6th, right? Power to a power, we multiply. On the bottom, 6 squared is 36, and x to the 5th squared is x to the 10th. Now be careful after you do these rules, especially when you have a fraction. You have to ask yourself, can you simplify? And we can. 9 and 36 are divisible by 9. And so my final answer here is y to the 6th over 4x to the 10th. And if you wanted to, what you could have done, which would have probably honestly been even easier, is just simplify 3 over 6 to make that 1/2 and then use the power rule. But either way, you got to reduce somewhere in there. B, okay, on B, just like here, I have no exponent rule of when I have the same bases, what to do with those exponents. So here on B, you got to use your order of operations. What's your order of operations? That's your please. Please excuse my dear Aunt Sally. So what do we got to do first? Exponents. So 4 squared is 16. 4 to the 0 power, that's not 0. What does that equal? That equals 1. And now I can add or subtract. So my final answer there is 15. C and D, you're going to have problems like this one. I think you're going to have just one at the very end. Okay, but what you need to do first is your power rule on the top. So don't forget your coefficients. 2 cubed is 8. Then 3 times 3 gives me a to the 9th. 4 times 3 gives me b to the 12th. All over -8 a to the 9th b squared. Okay, a to the 9th over a to the 9th, those cancel. And 8 also cancel, but don't forget that negative there. So I've got negative b to the 12th over b squared. That's this right here. That's your quotient rule. What do? We subtract. So 12 minus 2 is 10. So we got negative b to the 10th. D is the exact same thing. Distribute that 4 first. Goes to everything, right? So that's 3 to the 4th. 3 to the 4th is 81. Z to the 8 times 4 gives me 32. And then X to the 20th, 5 times 4. And this will stay all over negative 27. Z squared X to the 20th. Just like before, X to the 20th and X to the 20th, those cancel. 81 divided by negative 27 is negative 3. And then Z to the 32 over Z squared, subtract them to get Z to the 30th. Just a little hint, you are never fully simplified until you have one of each variable. Okay, so notice that like on this one here, even though I needed to simplify my coefficients, my numbers, you had a y on the top and an x on the bottom. So there's nothing more you can do with those variables. But right here, when you have a z on the top and a z on the bottom, a z or x and an x, you've got to dwindle that down to where you only have at most one of each variable. Okay, you're not done until you have only one. All right, that's all I got for this lesson. Next lesson, make sure you get really good at this, because next lesson we're using all of these rules and I'm adding just one more rule to it, but I am adding. So you need to make sure you are good at these rules so that when we add another one to it and they become more complex, we're not mastering these rules when I add more. This lesson, I'm not going to lie, has a lot more problems than usual. It has 20 problems, but these should not take you very long, right? When you look at like these first ones here, 4 plus 6, x to the 10th. That's quick. Power to a power, multiply. That's quick. Power of a product, you're multiplying multiple things, but that's quick. Power of a quotient, distributing that power to everything on the top of the fraction and the bottom of the fraction. That's quick. Quotient rule, you're subtracting. Boom, that's quick. Zero exponent, anything to the 0 power is 1. That's even quicker. So you do have 20 problems on for this assignment, but they should not be, should not take you a lot of time like with rationalizing the denominator. These are quick. So it's a lot more problems, but hopefully it will take you even less time than it took you to do 8 problems with rationalizing the denominator. I don't know if I said it or not, but if you have any questions, please feel free to contact me. I'm more than happy to help. I'll see you guys next time for the second part of this lesson. Bye.